Okay, let's begin. So we've been spending a lot of time talking about position time graphs. We've been finding the slope. We've been talking about average velocity, all that stuff. We're going to move forward now, and now we're going to talk about velocity time graphs. And we have been doing some graphing of velocity time graphs, but we haven't spent a lot of time sort of interpreting them. So that's sort of the next step. Okay? You should already know that average acceleration is calculated the same way that average velocity is calculated on a position time graph, and that is by using the slope formula. If you haven't figured out by now that slope is pretty important in physics, it's pretty important in physics, slope. You need to be able to calculate slope. Okay? So, on a velocity time graph, the acceleration is the slope of that velocity time graph, right? So, the acceleration for interval A, and you guys have this right on your paper, interval A is the first one, from 0 to 2 seconds. So the slope is up 4 over 2. I have an acceleration of 2 meters per second squared for interval A. So on the clickers, I've given you the first answer. All you got to do is type it in. You're going to get that one right for sure. Okay. I would like you to now tell me what the average acceleration is for intervals B, C, D, E, and F. Oh, and I'm giving away answers. I better not do that. So you may begin. I just have to set this up here. No, I don't want to see the answer key. All right, no big surprise there. Everybody got the first one right. If you got it wrong, then clearly you weren't paying attention at all. So yes, the slope is 2, the acceleration is 2. B is 0. You really don't need to calculate that. The slope here is 0, right? Number 3, the slope is minus 2. The slope here is minus 2. It's down 4 over 2 minus 2 meters per second squared. D, your answer should be a continuation. It's still minus 2. Right? This is a straight line. It's minus 2 above and it's minus 2 below. It's the slope. Minus 2. The slope of the next one is 0. It's flat. The slope here is 0. I'm hoping the reason people got these wrong is because they had the wrong interval maybe. That was for number 5, which is A, B, C, D, E. E is 0. F should be a positive value. Positive 1. Positive 1. We're going up 3 and over 3. All right. Number 7. When is this object stopped?
Never.
G. Never. And yes. Okay. Why is it never? This is a velocity time graph. It's a graph of the velocity values. So to be stopped, the velocity has to be 0. So during which intervals is the object got a value of 0? None of them. Now, having said that, it is momentarily stopped right there at 7 seconds and right there at 14 seconds, but it asks for what intervals. So it is not stopped for any length of time. Okay? Intervals. Not stopped. Don't worry, lots of people get that wrong every year. Okay? It's okay, you'll learn now. When is this object moving backwards? The correct answers are D, E, and F. Because again, this is a graph of velocity, so if it's moving backwards, the velocity would be negative, down below. Negative, down below. When is it slowing down? Here's an even harder question. Pay close attention here. Slowing down means that the velocity is getting closer to what value? 0. Here it's moving away from 0. Here it's a constant 4. Here it's actually going 4, 3, 2, 1, 0. That interval there, it's slowing down. It's going towards 0. So C and F are your correct answers. Not an easy question. It's okay. Now is not the time that you have to get it right. It's a little bit later that matters. C and F. It's getting closer to 0. That's what happens when you slow down, right? Your velocity gets closer to 0. Now, when is it speeding up? Speeding up occurs when your velocity either it moves away from 0, right? So there and there. A and D. Moving away from 0. Interestingly enough, in this interval here, C, right, it's slowing down. This interval here, it's speeding up. But what happens to the slope? No change. The slope does not change. Here it's slowing down, here it's speeding up. It's the value of the velocity that matters. 11, when is it moving at a constant speed? There and there, right? B and what's that? E? Okay? Those are wonderful questions to check later to see if you know what's going on. Put a big star beside that. That is important. Put a big star beside that in your booklet. Yes, I know. That was so. That's wonderful. Now let's talk about displacement. No, there's going to be more. Displacement. Watch very carefully when we talk about displacement. Displacement on a VT graph is determined by calculating the area between the graph and the time coordinate over the time interval in question. I'm going to say that again because I can sense that many people are not ready for this important information today. Displacement on a VT graph is determined by calculating the area between the graph and the time coordinate. The time coordinate means the x-axis. Displacement is calculated by finding the area. This is only true on a VT graph. Okay? Here's an example. The displacement for the time interval A, which is from 0 to 2 seconds, so this interval right here, would be equal to the area of the triangle formed by the graph and the time coordinate. In other words, the area of that red triangle. The displacement is the area of the red triangle. Let's have a closer look and see what's going on here. I start out at a value of 0, a velocity of 0. I start out stopped, and I end up going how fast? How fast am I going at the end of the interval? Put the phone away, sorry. This is really important. This is exactly what you didn't get yesterday. This is the same thing, trust me, says the teacher of 20 years. How fast is it going at the end, Sonia? 4 meters per second. I'm going to zoom in so we can make it a bit bigger. It starts at 0 and it ends up going 4 meters per second. How far then does it go in 2 seconds? The quick answer is 8, but that's wrong because it's not actually going 4 until when? At the very last instant. At one second, it's only going 2 meters per second. So it's how far does it go over that whole interval? I need to find the average. What's the initial velocity?
0.
What's the final velocity?
4.
What's the average of 0 and 4? 2 times a distance of 2 gives me a displacement of 4. Now it just happens that the whole thing works out beautifully, right? Because by taking the average, what I'm really doing is I'm making my line like that, right? That's what I'm doing. So, and you probably already know that the area of that rectangle would be equal to the area of the triangle, right? If I take this little guy right here, right? And put him right in there, it's the same, right? So a quick way to think about it is to think about the area of the triangle, and this always works. So it's half the base times the height. The base here is from 0 to 2. The height is from 0 to 4, so it's half the base, half of 2 times 4, which is 4. The displacement from 0 to 2 is 4, the area of the triangle. Now, what if there's more than one time interval to be used in the calculation of displacement? Then the total displacement is simply the sum of individual displacements. In other words, if I wanted A and B, I just find the area of A and the area of B and add them together. B is what shape, Larissa? B is what shape? Rectangle. What's the formula for area of a rectangle? Yeah, you do. Area of a rectangle. Triangle is half the base times the height. Rectangle is base times height, exactly. Base times height. What's the base? It's from 2 to 5, that's a distance of 3. The height is from 0 to 4, that's a distance of 4. So I get 3 times 4, 12. I get an overall displacement of 4 plus 12 or 16.
Can you just add 6 to 1? You add 4 to the triangle?
What do you mean by add 4?
Didn't you say you had to find the area for A and B?
Yeah.
Yes.
Where'd you get the add 4 though? Like where do you get 4? It's
Triangle.
oh yeah, okay, yeah. It's I thought you were at it's 12 plus the original 4. You're right. Yeah. I thought you meant this was 4 and I couldn't read it. Okay, 4 plus 12. You're right, Sean. Good. Okay, now I believe, if I'm not mistaken, what about below? What if it's below the graph? Well, then that displacement is negative, right? For example, time interval D. This is C. Now, this one is super important because I see this all the time. This is, I want you to shade this in. Do it on yours. This one is D, okay? When you're below the graph, you color above the line. You color between the line and the axis. Between the line and the axis. You're really kind of doing like introductory calculus here, by the way, just so you know. When you start talking about shading and intervals and integration in calculus class, it'll all come back to this.
Coloring and calculus.
Yes. Okay, so now because it's below, it's negative. The base is from 7 to 8.5. That's a distance of 1.5. The height is from 0 to minus 3. That's a height of minus 3. So I go 1/2 times 1.5 times minus 3. And the displacement below is minus 2.25. Does it make sense that it would be negative? Well, what's the velocity during this interval? What's the value of the velocity? It's negative. Negative velocity means going backwards. Negative displacement. Makes perfectly good sense. Okay. So I want you to find the displacements of all the remaining intervals. I want you to find C, E, and F. C, E, and F. C is this one.
Are these clicker questions?
They are. E is this one, and F is this one. I'm going to come back to those answers because I've got this little clicker thing split up this way. Okay, so the last little bit of instruction here. Average velocity. Whenever the average velocity is to be calculated under any circumstance, it must be done using the formula V bar equals d over t, where the displacement is calculated from the VT graph using the area under the curve technique. In other words, you have to find the displacement before you can find the average velocity. So for example, the average velocity for the time intervals A and B combined, so there to there. Now you might think, oh, well, I start at 0, I end at 4, my average is? Thank you, but you'd be wrong. Okay, because it goes 0, 1, 2, 3, 4, 4, 4, 4, 4, depending on my time interval. Right? It's at 4 for a long time. You can't just go average of the start to the final. Okay? Why not? Because it's not constant velocity. That only works for when it's, not constant velocity, but only works when the acceleration remains the same. Okay? And that's not the case here. So you have to find the area. So in other words, I have to find the area of A, which you have done already. It's 4. You have to find the area of B, which we've done already. It was 12, giving me a total displacement of 16. In other words, the area of that triangle, that area right there, from 0 to 5, the total displacement is 16. What's the average velocity? It went 16 meters. It took 5 seconds. The average is 3.2. Not easy stuff. I'll explain it again. Watch carefully. You have to take the overall displacement, the total area of that region from 0 to 5. The total area is 16, right? The 4 plus the 12 that we did already, and divided by the 5. So it's 3.2. 3.2. So question number 4 is determine the average velocity for the entire trip. You'll notice that it starts at 0, it ends at 0. Does that mean that the average is 0?
No.
Not necessarily. Not necessarily. You're going to have to find the total displacement. You should have 1, 2, 3, 4, 5, 6 different displacements that you can add together and divide by 14 seconds. You have to have gotten the other ones right to get this one right. This is question number 4. Question 5 and 6. These are, yeah, I should make these separate. Okay, let's just do this one. Let's just do this one first. Do number 4. All right, we'll give you the answers right away. Last couple here, instantaneous velocity. Instantaneous velocity on a VT graph is easy because a VT graph is a graph of the velocity. So instantaneous velocity, you simply read it right off the graph. You read it right off the graph. So for example, the instantaneous velocity at 6 seconds is equal to 2. So my question to you is, what is the v-inst at 13 seconds? What is the instantaneous velocity at 13 seconds? All right, and the very last one, instantaneous acceleration. How fast does it accelerate? Instantaneous acceleration is determined the same way off a VT graph that the v-inst was determined off the position time graph. So that is, find the slope. Acceleration is the slope of the VT graph. You may need to draw a tangent line if the graph is curved. Is the graph curved here at all? No, so we don't have to draw tangent lines, but if it was curved, we'd have to draw a tangent line. The instantaneous acceleration at 6 seconds is -2. How did I get -2? I find the slope of that line. The slope of that line is -2. So my question to you is, what is the instantaneous acceleration at 12 seconds? How are you going to do it? You're going to have to find the slope. All right, so going back to the displacements. Question 1, find the displacement for interval C. Remember, you have to find the area. The area of that triangle should be 0. Whoa, hold on, that's not right. 0.4? That's not right, is it? It's 4? C should be, let me see here, from 5 to 7 is the base of 2. 0 to 4, that's a base of 4, or height of 4 divided by 2. Should be just 4, right?
Yeah.
Okay, I have to fix that. That's no good.
Mine said it was 11 when I put 4.
Really?
Yeah, mine says 3.
Oh, that's weird. Okay, it's 4. I don't know what's going on there. Didn't flip the page, did it? Okay, 4. Good. Interval E, did you get -7.5?
Yep.
Okay, interval E is this one? No. This one, right? That one there. And interval F should be -4.5. -4.5. Okay, average velocity, what'd you get? Here's where you should have got 0.4.
I got 0.41 and it went wrong.
Because it says to 1 decimal place.
I didn't do that.
You should. You should read instructions.
I was reading the thing on my paper.
I get that. Okay? Maybe there was other people that had that. So what was your total displacement? You should have wrote it down there. What was the total displacement? You just add them all up, right?
0.575.
5.75?
Yeah.
Okay, and then divide that by 14, right?
Yeah.
Okay. Instantaneous velocity, -1. What did these other people say? -1. It's down below, right? -1. And the acceleration, 1. The slope of this is 1. Okay, I'm going to stop talking. I'm done. I know you guys are done. Tomorrow what I will do is, the next 2 pages in this booklet are so important that I actually copy them out and give them to my grade 12s. That's how important these 2 pages are. Okay? I'm going to wait till tomorrow to explain what they are. Okay? And then you're going to have some time to work through these graphs here at the back tomorrow.
Can you log out of
All right? You can log out of the clickers.